from the Howard Hughes Medical Institute. The 2010 Holiday Lectures on Science. This year's lectures: Viral Outbreak, the Science of Emerging Disease, will be given by Dr. Joseph DeRisi, Howard Hughes Medical Institute investigator at the University of California, San Francisco, and by Dr. Eva Harris, professor of infectious diseases at the University of California, Berkeley. The first lecture is titled Dengue Fever, Breaking Epidemic Cycles. And now, to introduce our program, the president of the Howard Hughes Medical Institute, Dr. Robert Tijan.
Welcome to the Howard Hughes Medical Institute and the 2010 Holiday Lectures in Science. A warm hello to our in-house audience of high school students that have come from throughout the greater Washington, D.C. area. And also greetings to our webcast audience, especially students at holiday lecture events all across the country, from Florida to Washington State, from Wisconsin to North Carolina, and so forth. As president of the Howard Hughes Medical Institute, I have the privilege of leading pioneering research as well as educational programs that have national and international impact, including these holiday lectures tailored particularly to high school biology students. To learn more about HHMI, you can visit our website, www.hhmi.org. The holiday lectures are a way for us to enthusiastically celebrate some of the best science that we do in our institute, and I'm particularly pleased to introduce this year's speakers. Two extraordinary teachers as well as researchers at the top of their game who are very excited to tell you about their work. Eva Harris is professor of infectious diseases at the University of California at Berkeley, and Joe DeRisi is a Howard Hughes Medical Institute professor at the University of California at San Francisco. Eva and Joe's themes will be the fascinating and sometimes scary world of viruses and how these viruses can cause disease. I think perhaps most importantly, we hope to also learn how we can fight disease. Now, I'm very happy to introduce our first speaker, Eva Harris, to deliver the first lecture. Eva has been a colleague of mine at University of California, Berkeley, and I've seen firsthand her passion and enthusiasm for science, particularly for the potential of science to improve the lives of ordinary people. As a young college graduate with a degree in biochemistry, when I first actually met Eva, she had begun to travel to Nicaragua to see if she could make a difference. And well, let's just say some years later, she's still working in Nicaragua from time to time, and I believe you'll see that she's clearly making a big difference. In her first lecture, Eva will take us to Nicaragua and tell us about the serious impact of a viral disease called dengue fever. Sounds pretty scary. I'll let her explain why this disease has become such a serious epidemic and where in the world it is headed. We now will have a brief video to introduce Eva before her lecture.
Nicaragua. It's a very beautiful country. It is the second poorest country in the hemisphere after Haiti, and so there are not a lot of resources, but we've been able to come a long way, as they say. We've really put the necessary resources together in such a way that it functions. A lot of effort on quality control. So we've essentially made up, I think, in quality for the resource constraints.
Porque me está explicando cómo es la relación con los CPC, con como las asambleas comunitarias.
I think that the key to success, if you wish, has been to really keep it at the grassroots level, and to then the primacy of the human relations that is always very important to me, and to kind of focus on results. You know, we don't come in at a political level explicitly, you know, we build from the bottom, and then any government can see the good that that's doing for their country. They can see the impact in the hospitals we work on and the health centers that we work with, on the people, so they can actually see that there's something positive there. I think that there's just an overall sense of moving forward in the health and education realm that many people can identify with. This lecture series, it's an amazing opportunity to be able to connect with and inspire a new generation to be interested in science and to be interested in global science and to be interested in essentially using their intellect and their capacity to change the world. And they can do that locally, they can do that internationally, but the idea is to essentially transmit the concept that with their lives, with their science, with their intellect, they can dream, they can have passion, and they can make a difference.
Thank you. It's really wonderful to be here. A great pleasure and honor, and I'm deeply grateful to Dr. Tidjane for inviting me and for the incredible team that we've been working with over all this time, and to HHMI for sponsoring this event, and to you for being here. So what we're going to talk about today is Nicaragua, is dengue fever, and I'm actually going to start with a personal story because, like you, I went to high school and then I went to college, and I graduated from Harvard with a degree in biochemical sciences, and I always have loved biology, how the molecules work together and how the cells work together in a body. But I've also been always disconcerted, and still am, by the great inequalities that exist in the world today in terms of wealth, in terms of opportunity, and in terms of access to science education. And so when I finished with college, I went back to New York, which is my hometown. And then from there, I went to Nicaragua because at the time there was a revolution going on and they were making great strides in the areas of health and education. And as Dr. Tidjane said, I wanted to make a difference. I wanted to see what I could do. And of course, I was hopelessly unprepared for what I found. But I had a vision, and that vision was to bring knowledge and tools and resources to the countries where the diseases were endemic, and to work with people there to understand what their priorities were in public health and what their priority infectious diseases were. And one of them was dengue virus. And so what is dengue? Well, what you see here are 2 patients with dengue. There's about 50 million cases of dengue fever which occur every year. And what we see is this is actually a very debilitating and painful disease. In fact, I've had it. But you usually survive, case in point. However, there is a worse form of the disease, and this can be actually fatal within 24 to 48 hours. And what we don't understand is why some people have this severe disease. And so there's a lot of issues at the level of the science, but there's also a lot of issues at the level of clinical management and public health. And so I tried to address all of those. And so what we're going to do now is look a little bit more in detail at dengue. So what you see is that it's essentially a high fever, acute onset, and then this muscle and bone pain. It's actually called la quebradora, or breakbone fever. You might have heard of this, and has a really extreme retroorbital pain, and it's very debilitating. But you do have these warning signs. For instance, this abdominal pain, vomiting, and especially fluid accumulation. Because what happens in severe dengue is it's essentially an aberrant immune reaction, which leads to leakage of fluid in your circulatory system out, and you end up with shock from low blood volume, and then it leads to death very quickly. So the big question is, again, how is it and why is it that certain people can progress this rapidly? So vamos para Nicaragua. So we're going to go to Nicaragua, and we're going to roll the video. I'm going to tell you a little about the country that we're going to visit. So what you see is the capital, and Nicaragua is actually one of the largest countries in Central America, although it's the least densely populated. There's 5 million people, and 1.5 million live in Managua, which is the capital. Now, Managua actually was decimated in 1972 by a great earthquake, which leveled it. And actually, there's only 3 buildings that are over 2 stories high right now. 1 escalator, which is a big sightseeing event. And you can see that there's a lot of just kind of open fields in Nicaragua, and very poor water management system, which in many other cities in the tropics, you actually don't have access to running water all the time. And therefore, people have to have their water stored in large barrels, which will store clean water. But as you'll see, what Emperatriz is bringing out here are larvae. And what these larvae are larvae for mosquitoes. And what you're going to see in the rest of this series is that these mosquitoes actually will grow up to become, in this case, Aedes aegypti. And Aedes aegypti is a prevalent mosquito throughout the Americas, a little bit in the United States, and what they do is they carry dengue virus. And actually, there's another culprit here, which is Aedes albopictus, which actually is prevalent and spread throughout all of your backyards, too. And in fact, you are very lucky today, because you'll be able to actually play around with the adult and larval forms of these due to the hard work of Laura Kramer and Robin Moody, who are here today to help us with this. But the main point is that we have these two mosquitoes, specifically these species, that can transmit dengue. And what ends up happening there is that we have, as with many infectious diseases, a pyramid where the very top is the most severe disease. And then underneath that, we have about 50 million cases of reported disease, and then we have unreported disease. And then at the very bottom of that pyramid are the people who we call are asymptomatically infected. So they actually get infected with the virus, but don't actually have clinical symptoms. Now, generally, that would be a good thing, because you'd think you'd be protected in the rest of your life. But in fact, with dengue, and this is the trick we're going to look at later, it actually puts this population at higher risk for severe disease. So why are we worried about dengue? Well, it's spreading out of control like a bat out of hell. And the reason is three different ways. We have an increasing number of cases, we have increasing geographic spread, and then we have this issue about co-circulation of the four types or the four flavors of dengue, and that's what causes these problematic immune reactions. So if we look at where dengue is prevalent in the world, it's kind of like a belt around the world, the subtropical and tropical areas. And in fact, we are lucky enough to have the vectors of dengue in the United States. And this is where the Aedes albopictus and a little bit of Aedes aegypti are in the United States. And actually, there was a big outbreak, or big for the United States, outbreak in Key West of confirmed cases, which actually, when they looked, there were a number of other people that had been infected. I should mention that in the 1700s, 1800s, and 1900s, there was actually a lot of dengue up and down the eastern seaboard, and yellow fever as well. And that actually gradually went away with increased socioeconomic status and water management. But it's something to keep in mind. So now what we see here in this graph, what you're looking at on the y-axis, is the number of cases in millions that are reported. And over here we have decades. And essentially what you can see is, although there's a cyclic nature, it's going up and up and up and up. And essentially now we're just out, off the charts here. The other issue, and what you're going to see, is the geographic expansion. What we can see is from the 1960s, you're going to see the spread throughout the Americas. And what you see is the red here means that there's a large number of cases, and you can actually see it spreading throughout all of the different countries in Latin America. And this is actually not only in the Americas, but also in Southeast Asia and the Indian subcontinent. So we have a huge geographic spread. And then the other issue is this co-circulation of the different flavors. So as you can see, we have 4 different flavors, dengue 1, 2, 3, and 4. They're otherwise known as serotypes. And the problem is that originally there were only a couple places where you had all of these 4 circulating at the same time. But now, essentially, all of these 4 viruses are everywhere. And the more that happens, the more you get the severe disease and epidemics of what we call dengue hemorrhagic fever and shock syndrome. Now, it's kind of curious as to why this arose. I told you that, for instance, dengue has been around for a very long time, but what was really curious was that it was the emergence of the severe dengue, of the hemorrhagic fever and shock syndrome, that got people really worried because of its fatality rate. And in fact, the interesting thing is that this actually came about because of World War II in the Southeast Asia, because the movement of ships in the Pacific theater moved the mosquito around to different countries. And then the movement of the troops, when they were viremic, meaning when they were actually carrying the virus in their own bloodstream, moved the different viruses around as well. And so what we're having today in the rest of the world is actually not due to a particular war, but it's due to our lifestyle, which has to do with global trade, global travel, and urbanization. So what you see here, for instance, is a picture of containers of the shipping industry. And here's a barge which has a bunch of old tires in it. Now, in old tires is water, and in the water is larvae. And the larvae grow up into mosquitoes. In fact, this is how there was a point introduction of a single ship from Southeast Asia that docked in New Orleans, and that's where the whole spread of Aedes albopictus into the United States came from. And so you can see that this global trade is a problem for the mosquito. The global travel, this is actually, it looks like my life, but actually what it is the amount of jet travel in a single day. Okay, and so you can imagine that this real-time spreads like the hot zone. It's true. You're actually moving virus all over the place in a very short amount of time. And then we have this issue of urbanization, which is that the greater and greater percentage of the world's population, you can see here on the y-axis, percent of urban population is going up 1950, 2000, 2030. In the whole world is increasing urbanization. And many of these cities have poor water planning and waste management. And the bottom line of all of this is that the vectors that transmit dengue are perfectly adapted to your lifestyle and to essentially human habitat. And so now what I wanted to do is to kind of go into a little bit more, why is it that these 4 different viruses can come up with this bad reaction? And so imagine that you have a person who's being infected by this red virus, dengue 1. So this person will mount an immune response and will actually either become sick with dengue fever or be asymptomatic, but will clear the virus. And so we're going to have the immune cells, the T cells, and the antibodies, the B cells, are going to remain in the body. So that when they have a second infection with that same dengue 1 virus, that red virus, then they can actually be protected by their immune response. And now, the problem, though, is that when you get a green virus, which is the dengue 2 virus, the antibodies and the T cells only partially can recognize, but they don't neutralize the virus. And because of this funny immune reaction, you actually end up with a much more severe disease in that situation. And what we're going to do tomorrow is look more at the molecular and immunological detail of that and how we can prevent this problem. But in the meantime, you can see that this is a friggin' complicated disease, right? I mean, not only do you have the humans, you've got the mosquitoes, you've got the virus, and then on top of that, you can see you've got individual risk factors. We have what we call epidemiological risk factors that have to do with the populations themselves of humans, and then we also have virus risk factors. So we have not only 4 serotypes, I wish it was that simple. Within each serotype, there's genetic diversity. So there's genotypes within the serotypes, and then there's clades within the genotypes, and there's strains within the clades, and these can actually have different potential for disease severity as well. So you get the severe disease only kind of when this all comes together as the perfect storm. So you can imagine that to understand this disease severity, you have to understand a lot of different factors. So when I started my lab working on this 15 years ago, I decided to take a really broad approach that would move from the molecular virology, where we understand how the virus actually replicates, to an animal model of the disease so that we can understand how the disease and the immune reaction can happen. And we were very concerned about having diagnostics out there to be able to identify the disease properly. And then to study with the epidemiology is really the study of human populations. And so what we tried to do here is to have a series of studies, which I'm going to tell you about in a moment, in the communities and in the hospitals, and then actually how we can do community-based interventions to stop this whole story. And then at the last piece, I'll tell you tomorrow about another effort, which has been to really just build scientific capacity throughout the world so that every country can actually deal with their own problems by themselves. So what I'm going to tell you about now briefly is our cohort study, and to kind of give you a sense of what this kind of epidemiological research looks like in real life. So this is just a picture. It's called an epidemic curve. And what you're seeing here, again, is cases on the y-axis. And then along the x-axis, what we see are months. However, each bar in this histogram is a single day. And what we're looking at is an epidemic in Rio de Janeiro in Brazil. And so every day, you're getting about 3,000 cases reported in a single city. Okay, and I just told you that there's way more cases than are even reported. So this is a really intense epidemic when it happens. And now you can say, do you see anything curious about this curve? So there's this dip here, and you say, well, that's kind of interesting. I wonder what happened to the mosquito, or do you think the virus was actually evolving in a certain way? I don't know, but you know what it was? Carnaval, that's right. You know, February, it's Carnaval in Brazil, and so people were sick, and they're going to their doctors, and the doctors are like out there sambaing, and like there's no one to report the dengue to, or maybe they were just like, you know, just go dance it off, whatever. So, you know, this is why we say you really need to know your own population so that you can interpret this in the proper way. But this is our own data. This is Nicaragua, and this is a cohort study that we've had going on since 2004, and we're following 4,000 children over time. And what you can see is that we have from about August to January of every year, we have a peak of dengue incidence. And what we want to do is we want to understand really the natural history of the transmission of this. And what we do is we call it a cohort study because you have a group of children and you follow them forward in time, over time. And this allows a very different kind of analysis than what we call a cross-sectional study, which is only one point in time. And you'll see why this is so important. So what we are interested in is to understand the spectrum of disease in children, to characterize the natural dengue transmission, to be able to investigate the immunological and the viral determinants of both dengue and severe dengue, and then also to be able to develop a site where we can actually test new drugs and vaccines so that we can prevent dengue in the future. So what do we actually do? Well, you mean we actually go to children's households, we collect and test blood samples, we provide medical care, and we establish what's called good clinical and laboratory practice, which is a very kind of high level of standard so that we can participate in international studies and trials. So the way the design of this study is such that we go forward in time, like I mentioned, and then every year we take what's called a healthy blood sample. So why do we do that? Well, we collect antibodies and immune cells, which are in the blood, and we gather data. And then what we do is we measure every year the number of dengue antibodies. Now, this also has a service for the population because we test for hemoglobin. And hemoglobin will tell you whether your child is anemic. And if they're anemic, then they get iron supplementation. So this is another really important part of our work. And I think that anyone who works internationally or just in communities should keep this in mind, that what you do is you have a scientific reason for doing it, but you also must give back to the communities and to the countries in which you work. And so that everything we do has a scientific objective and then essentially a giving back objective. And so this is useful for the families themselves. But it's useful for our science because what we do is we look and we see if we measure the antibodies in year 1 and year 2. And if we have an increase by 4-fold or more in antibodies, that means that that child was exposed to dengue virus, mounted an immune response, and we can read out that immune response by an increase in antibodies. So we know that that patient or that child had an infection between year 1 and year 2. Okay, now what we do is we actually can follow these. They come to the health center every time they have any kind of a medical anything. So we have thousands of consults. But everything that looks potentially like dengue or a fever, we actually work it up and we look for dengue antibodies and for virus in that sample. So what this allows us to do is to identify all of the children that had a symptomatic case of dengue. Okay, so now when we compare that, what we can see is we can calculate the total number of infections, and then we can calculate the kids that actually got sick. And then we know by subtracting that the kids that actually were infected and never got sick. And then we can say, now what is it about those kids? What did they have in their antibodies or their immune cells that were able to protect them from getting sick? Or what is it that these children had that allowed them to get sick or even to have severe dengue? So for the scientific objective, we can then look at the immune factors and the viral factors that differentiated these children who either were infected over the same time period, either got sick or didn't get sick. And that's really important for understanding how to make a good vaccine or how to treat people. Now, what it also serves, though, is, as I said, something useful for the country. So what you're seeing here is a graph where we see on the what we call the x-axis all these different health centers. So there's 21 health centers in the whole city of Managua with these 1.5 million residents. And what we're looking at in the different colors are the number of cases that are reported to the health system, okay, in different colors. And so now what I'm going to show you is our cohort study. Wow. So do you think that there's actually a lot more dengue right in the health center where we're working? No, that's right. No, in fact, I can show you because this is the health center, only the kids that weren't in the cohort. This is because we're actually testing for dengue and looking for dengue. And what we see is that there's actually 20-fold more dengue than anybody's actually aware of. And this is really important because when you want to actually make a case, an economic case to make a drug or a vaccine, you want to be able to say, look, it costs this much. And if you're off by like 20 or 50-fold, that's a problem. And as a Ministry of Health, you also need to know how much disease you have in your country. And this is not just in Nicaragua. It's actually now there's studies coming out in all countries that have about the same effect. So this is really important for the ministries to know. The other important thing, and this is my last piece of data, is that in fact, a lot of childhood dengue actually doesn't actually look like the dengue that we have as our case definition. And this is, I mentioned that part of the study was to look at what does childhood dengue look like. And you can see that these are laboratory confirmed cases. So we look for the virus, we look for antibodies, we can say you had dengue. Now, did it look like what we think dengue looks like? Well, if you're 11 or 12, yeah, maybe it does. But in fact, when you're really young, maybe you're not saying, I have myalgias and arthralgias, and I have, so you actually are reporting just a fever. And in fact, more children have a fever that doesn't look like dengue, and they're never even being recorded. So now on top of this 20-fold more dengue than we even thought, now we're fully missing 25% or a quarter of all of the childhood dengue that's out there. Okay, so this is actually useful for clinicians and for the Ministry of Health, et cetera. So what I wanted to show you is how we can actually use this kind of study to be able to have direct healthcare benefits, to deliver important epidemiological and clinical data to the country, and then also to be able to set the ground for the immunological and virological research that goes on in collaboration between my lab at Berkeley and our colleagues in Nicaragua. So that was what I wanted to start with, and I think we're going to stop here for a couple questions, and I'm going to just open the floor to see if A, you understood, B, you have any curiosities, and I'll be able to take a couple questions. Yes?
I was wondering, since there are 4 types of stereotypes of dengue, if a person had 3 types of dengue, they got the 4th one, would the reaction be worse, or would they be used to it since they have 3 different strains?
Can I hire you? No. That's a brilliant question, because it's exactly what we're trying to figure out, and it's exactly what this cohort can tell us. It's been thought that it's the second infection that's the worst. And because essentially you have a certain set of antibodies, and we'll talk about this tomorrow, but they can essentially create this over-exuberant immune response. But the thought is that once you get to 3rd and 4th infections, there's kind of enough cross-reactivity that you are protected. But that's kind of dogma, and we don't know. And the coolest thing is that now we're 7 years into this cohort, and we just got funded for another couple years, and what we can actually do is prove whether you have less dengue when you have more infections, because that has big implications for vaccine development. Like, what if you actually don't need a full response to all 4 viruses in a vaccine, because you have to give all 4 viruses together. So what if you could really only get 3, and that would still be protective, for instance? So it's a really good question. Yes, fine.
If you were going to do a vaccine, would you do like a live vaccine, or would you do more of a dead one?
Yeah, so the leading candidates right now, in fact, there's a phase 2B trial and one going into phase 3, which are live attenuated vaccines. And so the one that's going, so these, what that means is that you have a vaccine which is alive but doesn't make you sick. And that actually allows you to have a very good antibody response and a T-cell response. And so those are the leading candidates. But the problem is that since you have to put all 4 together, and they're live, they actually interfere sometimes with each other. And so, meaning like the immune response can get muted to one or another. So there's other sets of kind of what we call 2nd generation vaccines, which are subunit vaccines and a prime boost strategy. So there are kind of 2nd generation vaccines that are exploring other approaches.
It would be like a every 3-month type thing?
No, you would actually, well, unfortunately, you often need to boost, which is another issue with these. So right now, you need kind of 2 boosts to get the best reaction. But the idea is that there's these live attenuated and then others, which are subunit or killed vaccines, which are being tried as well. Okay, yeah.
My question is regarding funding. When I hear you travel in Nicaragua, you go all over the world, and I'm wondering who funds you, who gives you the money? Is it from a grant or from an institution?
Okay, so see these dark circles under my eyes? I write lots of grant proposals, anything. I mean, this work in Nicaragua for me is like the most important, and so and at National Institutes of Health, I get a lot of funding from them. There was a pass-through organization through the Gates Foundation, which for a while was supporting this. WHO, anything. Foundations. We have a foundation in Switzerland. If HHMI is interested. No, just kidding. Anything. I'll do anything to continue this work and to keep working in this. But it's as with anything, you got to work hard to find the money. Yes, in the gray sweater.
Is global warming the reason why this virus has come to the United States?
Very good point. Actually, it's not. There is spread of the vector of the mosquito, yes, because of global warming. But actually, the reason that we don't have disease as much in the United States and the reason that it got wiped out here for a while is actually because of socioeconomic status and because of the way of life. So for instance, the big change was screened windows and air conditioning and not being outside while the bugs were biting. So in fact, you can have virus like albopictus is all over Europe, albopictus is in the United States, and it has the potential to cause disease, but not as much because people are simply not in contact as much as they are like in Nicaragua, where there's like no window. It's just it's always open, and so there's no idea for screens or anything. But that's a very good. What good questions we get here. Excellent. So. Now, what do we do about this, right? So what I'm going to tell you about is this community-based intervention that we've been working on in Nicaragua to try and address this issue of in the here and now. I mean, we're working on vaccines, right? But that's not now. So how can we actually prevent this disease in the moment? So, well, I told you about this problem, right? Global trade, urbanization, and you can see like a lot of the trash, for instance, is plastics and the tires and all of that can actually be breeding grounds for mosquitoes. So when you look here, this is a picture similar to what you saw before. What you see is Latin America, and what we're looking at now is the distribution of this mosquito, Aedes aegypti, in the 70s and then in the late 90s, and it's actually worse now. Now look at this. This looks real similar, right? This is where the disease is. So this shows you that where you have mosquitoes with the right conditions, you have disease. And it also shows you that if you can get rid of the mosquitoes, you can get rid of the disease. So even though having the mosquito, it's a vector-borne disease, the mosquito is transmitting the virus and making things more complicated, it also actually gives you another entry point for control of that disease, right? Because now you don't only have the human and the virus. If you can get rid of that central point, which is the mosquito, then you can also control the disease. So actually, this is interesting because the reason that this looks so nice and clean is because there was a huge campaign in the Americas in the 60s to get rid of Aedes aegypti because it also spreads yellow fever. And there was a lot of fear about yellow fever. And so the big campaign, a lot of insecticides, DDT, the army involved. But what happened is that it was very effective. But then once they stopped paying into this and actually supporting this, and it was very expensive, boom, the mosquito came right back. And on its tail came the dengue. So another thing at the kind of more micro level, that was like the whole continent, right? Now let's just look at Fortaleza, Brazil. This is the work of Pontes et al., which was published in 2000. And what you can see here is this is the effects of a government-run program where they're coming and sending out teams that go into people's homes and they get rid of the water where, remember how you saw that larva growing around there? So they get rid of where the mosquitoes are growing. And then you can see that when they have what we call 100% coverage, that means they're whatever percent coverage, the teams are going into those homes and getting rid of where the mosquitoes breed. And what you see as a result is that if you then measure how many houses have mosquitoes growing in them, you can see that there's an inverse relation. So if you get rid of where the mosquitoes breed, you tend not to have mosquitoes and vice versa. And now let's look at dengue. So you can see that pretty much, whenever you if you do not get rid of where the mosquitoes breed, there's mosquitoes and then there's dengue, okay? And then conversely, the opposite. Now this actually shows you that you can be effective, right? If you get rid of mosquitoes, you don't have dengue. However, when you depend entirely on an external force, this is a problem. Because if you look here, what happened here? Well, there was a cholera epidemic. So all the public health force went, whoop, cholera. And then what they do? Well, they didn't check their houses, and then they got a big dengue epidemic. Okay, so you need to actually transfer the responsibility, from this kind of top-down situation into the communities. But first, what we need to understand is the mosquito life cycle. And this is something, like I said, those of you who are here, are going to have a really fun time playing around with this. But if we roll this video, what I'm going to show you is how the mosquito goes. So this is the mosquito at the end of the day. But actually, it lays eggs. And these eggs grow, and they can actually be desiccated, and then they come back with presence of water. They actually can then emerge and become the larva that you saw. So this is called the larva, and this is its siphon here, and it's breathing the air. And what it'll do is it'll grow in clean water, especially these Aedes aegypti grows in clean water. And you can see, and actually it's cool because different species actually dance differently, but then they become pupa, and the pupa, you can see, will then split open on the back of the exoskeleton, and they will actually emerge into mosquitoes, and the mosquitoes will then land and will probe. And what you can see is now what happens to the virus as it enters the mosquito. So it's going to enter, and it's going to go into the midgut, and then it's going to start replicating. And it's actually going to go out through the midgut and then disseminate to the other body organs. But the most important is that going to the salivary glands, because then the salivary glands will then allow this mosquito to then deliver the virus back into the next person that it bites. Okay, so that's how it works. Now what we're going to go on is there's a lot of posters. This is a poster from Brazil, and they're right on. They say stop the mosquito, and then you can stop dengue. However, when we actually went out into all of the barrios, we call the neighborhoods, and you get out, when we started talking to people, and we're saying, what is it you need to know? Like, what do you need to know so that you can actually do some kind of intervention around dengue? They were like, it's not the mosquito, right? It's the life cycle, because what matters, all of those interventions are about the water. Like, no one's running around swatting mosquitoes. They're actually getting rid of the water where the mosquitoes breed, and yet no one had ever told people that the mosquitoes breed in water. And so, like, why would you spend all your time running around, with the water and all this work when it was like completely illogical, but yet it had never occurred to any public health campaign that was illogical, right? And so finally we're like, oh, now we get it, and bing, that big click was, now all the kids, this is Nicole, is explaining the eggs to the pupa to the larva, and it takes about a week, a little bit over a week to get the pupa. So you don't actually need to be scrubbing around and getting rid of the water every day. You just do it once a week. And as long as you can cortar el ciclo, as long as you can cut the cycle every week, you'll never get pupa or mosquitoes, right? So that's totally logical. And once you deliver it in that way, and it wasn't even our idea, right? It was the community saying, oh, now we understand. To get rid of the disease, we need to get rid of the mosquito. To get rid of the mosquito, we just cut the life cycle. And that became the whole issue that they were working around. And what you see in this video is we worked with a number of different barrios and the different residents, and they came up with just phenomenal ways of expressing this. This is the life cycle, and this is, they're telling you, this is how you scrub the barrels, and this is what you do. So there's like all these cool different ways that they had to transmit the information about, how this thing is spread, what are the interventions that you can do. They made these stencils, and they put them up all over Managua to explain the life cycle and how you can cortar el ciclo. They made posters, and then they went, resident to resident. This is what we call a brigadista, and she's a total reggaetonero, but she's out there like explaining the life cycle and getting down with the people and showing, if you just take your clean water in your very own household, you look and there's these friggin' little things in it. It's so gross. People get really upset by, it's very motivating to see that their own water is full of this stuff. And so then they get really motivated to actually do something about it. And this is Magdalena, who's been working with us for a while, and she's, explaining in every household how this thing works. And so what I want to contrast for you now is this kind of top-down approach, which we saw, which was, this kind of Pan-American approach, or the Brazilian Ministry of Health coming in. And, what happens there is that it's often effective, but it's large and vertical, it's expensive, and it ignores the communities and the differences that we have, and it has often a short-term impact, like we saw with both of those cases. So the alternative is to do what we call a bottom-up approach. And this is where you actually work with local leadership and local people, and this really involves an intensive community involvement with responsibility. It's adaptive, and it can actually be sustainable. So if we just take that concept of the top-down and the bottom-up, and then we translate that into mosquito control, let's look at what that seems. So we have a traditional institutional mosquito control, which actually relies a lot on chemicals, which are actually not good for your health, turns out. The larvicides are put into drinking water, and they're potentially harmful. It's resource intensive, and it's actually unsustainable. And we contrast with the community-based approach, which is actually very importantly evidence-based. Like I showed you, you show people their own evidence, their own larvae in their own water, and they actually then get motivated to do something about it. It's peer-led, and it's what we call green, because it actually doesn't depend on insecticides or chemicals. And actually, I'm going to show you some data that actually shows that it's equally effective, if not more, than the traditional approach. So this sounds fabulous, but what's the difference? I mean, the problem is this motivational gap, right? I mean, man, you come back, you're tired. I mean, then you get out, it's like 100 and something degrees every day. You don't want to be like scrubbing the barrels and like emptying. I mean, why are you going to do this? I mean, you might know it, but to get the energy to do it, you got to be like motivated. And I mean, it's the same thing, right, with STDs, HIV. You know you're supposed to use a condom, but like, does everybody always use a condom? I mean, there's knowledge and then there's practice. And so the big question here is, how do you actually bridge that bridge between the knowledge and the practice? And so what we came up with, we meaning the communities that we work with and the nonprofit that we worked with called See It, and ourselves, was this idea which is called SEPA, which is kind of a mouthful, socializing evidence for participatory action. But in Spanish, the word saber, sepa, is actually to know. So it's kind of a little trick on words there. And so the idea was to motivate the community participation in mosquito control, to use this in an evidence-based approach, which was actually going to use as evidence people's behavioral and knowledge and their capacity to control dengue, the mosquito indices in their own homes. And another thing that we added, which was the level of antibodies to dengue virus in their children's saliva, which allowed us to show them whether their child had gotten infected in a certain point of time. And so that was like really motivating to know that your own kid had gotten infected with dengue or not. And so this kind of evidence was what really was the click for motivating. And then the idea was that they would then come up with the interventions, and that it was actually, then they would do it year after year, and they would refine it, and then as they refined it, they actually learned this whole methodology of translating evidence into action, into policy. And so what I'm going to show you now is kind of how this worked. This is the greater Managua area, and we chose representative sites, so we call them barrios. They're really just neighborhoods, and we took 120 households in every one of these 30 neighborhoods, and we chose 10 of them that were where we did what's called the intervention, where we did the action, and then 20 of them where we did not do the action, and those served as our controls, or what we call our reference neighborhoods. And you can see that they have very different socioeconomic levels. Sometimes have the dirt roads, some are nicely paved. And this is actually based on a lot of data. This is 4,000 households that represents 23,000 people. And then every year we do a cycle where we measure all of the larvae and the pupa in 26,000 water containers. So this is actually based on some heavy numbers. We take these saliva samples from over 3,000 children, and then we combine all that data together. And the way it actually works is that this went on for 4 years, and now we just got funded to do what's called a random controlled trial, which can actually prove that this does or does not work. But this was our pilot study to see whether there was actually something in this approach. And so we do these measurement cycles every year. We do the household visits in October and February. What I'm going to show you now is the data from the water container inspector we call entomological surveys. Entomology is the study of insects, so these are looking for the insects in these people's homes. And then we also went twice to collect the saliva from the children. And remember how I showed you in our cohort study, we compare 2 points in time and we look for an increase in the number of antibodies against dengue. So we do that here too. We look and see whether there was an increase in the number of antibodies against dengue, and then that shows us that that child was infected during that time period. Okay, so that's where the evidence comes from. So what you can see is now we're going to look at this question of the children's infection rate with dengue. Because it doesn't mean that they necessarily were sick. It means that they actually experienced an infection. And again, remember, if they've had an infection, that puts them at risk for the more severe disease. So this is actually important. And so what you see is in the year 2004, when we started, we're looking at the relative percent infection in our reference and our intervention sites. And of course, there's no difference, right? Because we didn't do any intervention. So everything's the same. Now, however, in 2007, and we actually saw this change happen right away, we actually get a 60% reduction in the children that were infected with dengue in the barrios that did the activities versus the barrios or the neighborhoods that did not. Okay, so that's pretty profound effect. You can actually reduce the number of children infected with dengue if you do this kind of activity. So another thing that was important as evidence is now, so that was the infection rate in the kids' saliva. Now let's talk about those entomological data, or essentially the data about how much larvae and pupa are growing in these homes, okay? So what's interesting is if you look at the intervention in this case, which is the CEPA movement, we can see now on our y-axis is the percent of, in this case, barrels that have larvae or pupa in them, okay? So if you do this program, you actually end up dropping down by about 1/3 the number of barrels that have larvae in them. And now if you look at the houses, right, so barrels are where they have the clean water, but the house is really what we care about because that's where people live. And you see exactly the same reduction. About 1/3 of the houses essentially have less larvae growing in them. So now we compare that to the traditional approach, which is to go in and put larvicide inside the homes or in the drinking water, which again could be a health risk. And you see that if you put the larvicide in the barrel, you get a reduction in the number of larvae. That makes sense. But now look at this problem. If you actually look at the houses, there's no effect. So that's like, first like, wow. And then you think about, what's the mosquito going to do? I don't want to go here. I'm going to go over here and lay eggs in this water, right? So, so your barrel doesn't have the larva, but another receptacle in the house is producing all of the mosquitoes. So it's really important, right? What we care about is whether the house is positive for mosquitoes, not necessarily if just one container is positive. And so this shows you that this is actually a more effective approach because it's taking the whole house as the entity for activity, not just a particular receptacle. So this way shows that this actually works. And now we're going to show you is how this works. And we're going to go a little bit back because what we do is we then feed back this information from the serology, from the surveys and the entomology. Again, we analyze the data together with the communities. And then again, they come up with the interventions. And then they do this every year over and over again. We actually first started this working with a nonprofit called See It, and we sent a facilitator, got integrated into the community and identified who it was in the community who was actually cared about health in their community, and these were called the brigadistas. But really soon, we actually withdrew the facilitator, and it only became a delegate from the barrios that came to see it. And so essentially, after 1 year, we transferred the whole authority for making the decisions, how they're going to do the entomology searches, everything. All the decisions were made by the people who lived in the barrio right away. And that's how this worked, because the thing, nothing's going to work unless you have real ownership and buy-in from the people doing it. And to do that, they need to own it. They need to make their own decisions. And so that was the whole point here. And they did it together with, whatever kind of organizations happened in that community. Sometimes it was churches, sometimes it was schools, sometimes it was dance organizations, sometimes it was, whatever was working. And every barrio is different, but it didn't matter. Everyone came up with their own solution once they understood what the problem was. But the cool thing is that when you get the whole neighborhood involved, there's all kinds of good stuff happens because it's really about social mobilization. It's about getting people involved. And so what happened? Well, a lot of these are really poor communities. They have a violence problem and a lot of gangs. And so what ended up happening is that in those barrios, the gang members actually became brigadistas, and they actually started working, going to people's houses. This is the larva, ma'am, and so they actually became a real social positive aspect. In Nicaragua, there's a lot of very different religious and political views, and often people are like super polarized along those lines. But actually, since they were all working together with this common goal, they forgot about those differences and they worked together. It was really nice. And over time, actually, the brigadistas, even though they were not necessarily literate, they became known to the whole communities, including the Ministry of Health, as the person to go to for a health problem. And so then they became invited to sit on the boards of the Ministry of Health and all this. And then they really importantly, since they were managing their own money, it was like $50 a month, to buy soda after they went and helped the residents figure out whether they had larvae in their homes. But they learned how to do financial management. And then these same groups then made cooperatives, sewing cooperatives, others, so that they actually became their own economic systems as well. And so what I'm going to show you now is what these brigadas look like. So you can see that they're going to be very different types. A lot of children got involved. It really depended on what the neighborhood was like. So we have the children involved. This is Juan Emilio Melocal, which is one of the barrios with a very active group. This is Maria. She's one of the brigadistas. And her mom used to say that she could only do this with the sinks because if she was going to do this with barrels, she might fall in and drown. So, she was only the one who could do the sinks. This is a woman, she's looking for the eggs because the eggs sit there. And now what do you do? Remember how the tires have water? What do? They fill them with earth. Duh! No one had thought of this. It's brilliant. You make stairways out of old tires. You fill them with dirt, and then there's no water inside them. They made elasticized covers for the barrels, and then they were able to sell them, and then they formed a sewing cooperative. It was totally cool. And then we have these fabulous parties every year called encuentros, and you can see that they come up with all kinds of ways to actually get rid of the mosquito. So again, I have nothing to do with any of this. Okay, and so now in the next one, what I want to end this series with, or this lecture, is so this is Israel Rodriguez, and so I spend a lot of time in Nicaragua, and these guys get to know me. And it turns out that they find out that I grew up in New York in hip hop era, and I love dancing. And so every year they would come up with a new reggaeton, which is Latino hip hop, on dengue for me. Okay, so this is my favorite, and I'm gonna show you because it's really cool. We added subtitles. So how many of you speak Spanish or understand Spanish? Que bien. Bueno, what you're going to see nonetheless is in English. We have subtitles that are going to tell you, and it actually tells you what to do to get rid of the mosquito. It's really cool. So, hit it, Israel.
Nicaragua, el ciclo de vida de los clavitos tenemos que cortar, porque a los 8 días en pupas se convertirán y a los 11 en zancuda evolucionarán. Y si no tenés cuidado, el dengue te transmitirán. hoy, Eva Producciones.
I didn't ask for that. I just gave them a little money to make a CD, and this is what happened. So anyway, so you can see that it really is infectious. People get the idea, and then they have all different kinds of ways that, like, I certainly didn't dream of. And so with that, I'm going to end this particular piece of the lecture and see if this has incited any questions in your minds. Yes?
I was wondering, can dengue fever only spread through mosquito vectors?
Yes, actually. Right now, that's the only way. You actually will get kind of what's called focal transmission in a household, but it's not because it's going from person to person, but rather because the mosquitoes that are infected will get infected in that house and will spread, around those houses in that area, for instance. But for right, as far as we know, it's really mosquito to human. Good question. Yes?
You mentioned that there were some cases where the children were asymptomatic to the cases. So have you made any discoveries to what those children have in common that makes them asymptomatic to them?
That's exactly where we're going. We don't have the answer yet, but we finally have set up a whole series of techniques. And in fact, Joe and I are thinking of collaborating in this area that can look at what we call the repertoire of antibodies and of B cells, for instance. And so what we're trying to understand is there a certain type of antibody that is more effective or less effective? And we have some inroads into that, because it looks like there is a certain, as you'll see, there's a virus and an antibody will interact with a particular part of that virus, and there are certain what we call epitopes that can be more neutralizing or more enhancing. And so it's actually, we're finally getting an array of technologies that can actually use these whole serum samples. A lot of times you look at a single antibody, like a monoclonal antibody in a single virus, but what we want to look at is the whole gamish, and so that's what's been like challenging, but now we finally have a bunch of techniques that we can actually apply to the serum to ask exactly that question. Good. Right behind you.
From an earlier question about global warming, if they did put screens on the windows and if the barrels were inside the houses, would there be more cases of dengue, or would that kind of...
Yeah, see, it's hard. I mean, there's a lot of things you could think of if you had the resources to do them, and so, and for instance, in industrialized countries, that is an option, or just making sure that you have 24 hours a day of water. But in many countries, there's huge poverty and a lot of big issues, and so you push on that side as well to do poverty alleviation programs, and that will have an effect. But in the meantime, no one's thinking of putting screens in every window in Managua. So the idea is, to clean up in the meantime, where they're breeding outside. Good question. Okay, yes.
Do the symptoms or the risks change as you get older?
Very good. Yes, actually. You tend to have, the children tend to shock more easily, and it has to do with the fragility of their capillaries. So that like what I didn't show you is that you have a big peak in infants, for instance. It has to do also with maternal transfer of antibodies that can make enhanced disease. But in children, you also have more fragile capillaries, and you can go into shock easier, which is why a lot of emphasis has been on pediatric dengue, on children's dengue. When we did studies across all ages in Nicaragua, and this has been shown in others, adults tend to bleed more. So you get more internal bleeding, especially in the GI tract, and just bleeding out more in adults, for instance. So a very good question. Okay, yes?
Why is dengue spreading back in the United States if we have clean water systems and clean hospitals?
Yeah. Exactly. So that is one of the questions that a lot of people are starting to look at now. And I mean, essentially, if there's just a lot more dengue circulating in the world, so then you're going to have repeated introductions. So if before you only had, one person every 20 years who might have been in Asia and come home, but as you see that the number of cases is going up, so you have a lot of travelers that are coming back, and the more and more times that you start reintroducing, one of that's going to escape. There's some really interesting studies I can talk to you about later. Okay, I got to go somewhere else in the room. Yes, go for it, whoever.
So is dengue as big a problem in rural areas? And if so, how does the SEPA objective work with that?
Yes, a very good point. It's been always thought of being a big urban problem, but a lot of it has to do with how the water is stored. For instance, in Cambodia, there's an interesting study that's just coming out, how it's in rural Cambodia, there's a lot of problems also, and they have these kind of ceramic places where they store water, which are really great breeding sites for the mosquitoes. And so as long as you have a certain level of a density of population, you can get the transmission. It just gets worse when you're in an urban situation, because there's just that many more people and that much more transmission that can happen focally. good point. Okay, yes.
You say that they dump out the water, but what if they need that clean water? Like, what if they don't have access to more clean water and they can't dump it out?
Right. Very good point. So a lot of times, at least, so many many cities will have intermittent water. And so for like where I live in Manawa, you have like 11 hours per day of water, you know, so you just time it so that you're scrubbing it and then you're refilling it during that time. And that, you know, but that's a good point. If you're kind of messed up, I won't use any other words. If you don't have water at all, and then what you do is that you're very careful about how you seal the barrel. So what's called hermetically sealed means you put something where like nothing can get in. But it's really important because we actually did a study and we found that if you had a badly placed lid, you actually had more larvae than if you had, so that's why I really like that elasticized material, because you can think of trying to like get some like metal thing that's like perfectly, whereas if you just think, oh, that's cool, elasticized material, it does the same thing. So those are the two kind of options that you would have. One more question. Okay, yes.
As people get older, they get more fragile, so would they be more prone to dengue as little kids?
Yeah, but there's actually an interesting thing about who mosquitoes bite more in terms of there's an age relation there. But what happens is that as you get older, at least when you have a lot of dengue, is that you're already immune. So that you really see the worst dengue in children. Although in new places where dengue enters, then you start seeing adults. And in fact, you do see it in elderly. And like in Puerto Rico, when it first started coming in, you would see dengue and severe dengue in elderly people. But what generally happens is you get so much that by the time you're even, like in our situation, by the time kids are 10, 97% of them have been exposed to dengue. So you can imagine that just by the time you're older, you're just like either dead or immune, Okay, thank you.
Wow. I think that's the first speaker we've had who danced. Eva, that was a fantastic lecture to start off the series. I think it's not often that we get to see the convergence of science, which you'll see in a subsequent lecture by Eva, and social issues, which I think we can all relate to. So thank you. And really, as always, I thank the audience. I mean, there were so many more questions that you would like to have fielded, but please search Eva out and ask her these questions that you didn't have a chance to do so. And I have to tell you, I'm kind of a mosquito magnet, so this is really freaking me out. So, in the next lecture, Joe DeRisi will take us deeper into the realm of emerging viruses and show us how new technologies are revolutionizing our ability to hunt for new viruses and to quickly identify them.